Hey guys, let's take a look at domain this week. And this is a sometimes confusing concept. I've tried to break it down, really make it really simple for you. We've talked about functions briefly, and this is kind of a part of that whole deal with functions, and this will help you understand what's going on with this. The first part we're going to talk about is called domain. And look at the question on there. Your mother gives you 25 cents to buy eggs. Eggs cost 10 cents each. How many eggs can you buy? Okay. Now, the answer isn't as obvious as you think it is, but there are actually three possibilities. You have a quarter. Eggs cost 10 cents each. How many eggs can you buy? Well, possibility one is, of course, that you could go out and buy 2 eggs, right? You'd have 5 cents left over. Possibility two is that you could buy 1 egg. You could just keep the 15 cents and use it to buy a new car or something. Possibility three, of course, you could just buy no eggs at all, right? So there are different things you can do with that money. And what that tells you, that's just a simple way of expressing the idea that the domain of this is 0, 1, and 2. In other words, 0, 1, and 2 are the possibilities you have. And that's the way it works with algebra and calculus and trigonometry and all that kind of stuff too. There are certain things that you are allowed to use this number, and that number in your equation or in your problem or whatever. Whether it's biology or chemistry or doing experiments or whatever it is. So sometimes there are just limitations because, for example, let's say, oh, you're allowed to use any temperature as long as it's above 32 degrees because the experiment will be ruined if you don't, and so on. So that's what a domain is. Domain is basically, if you want to write this down in your notes, this is about as simple a definition as you can find anywhere. A domain in math is what you are allowed to use in that math problem, or biology experiment, or a chemistry problem, or whatever. So a domain is what you're allowed to use. Now later on, we'll go, the range is what you get when you use a 0, a 1, or a 2. And we'll talk more about that later. So if you even want to think of it as an x and a y, d comes before r, x comes before y. In other words, x is what you put in, y is what you get when you put that x in. D is what you put in, r is what you get from that. We'll talk more about how that works in a few weeks, I guess. But we did the egg example already. Here are a couple of other ones. A domain is 0, 3, and 8, for example. That's the set that you're allowed to put into this certain math problem. All right. You might have something like this. D is equal to reals. By that, they mean all real numbers, which is, again, if you remember, that's anything you want to on a number line, left or right, anything in the whole world. All right. So those are all possibilities. You could have something like this. The domain is, in other words, what you're allowed to use is any positive integer. In other words, 1, 2, 3, 4, 5, and so on. It might be that a certain experiment or problem won't work unless you only use positive integers in that. Those are all domains. Okay? This is what you're going to do. This is how we're getting down to the nitty-gritty here. So this is what we're going to work on. They will tell you graph x is greater than 2, and the domain is real numbers. In other words, what you are allowed to use is all real numbers. So when you do this, just don't make this complicated. Just write a real simple number line. Okay, you're going to graph x is greater than 2. Okay, remember it doesn't include 2. So your domain is all real numbers. So what you're going to do is just going to go, well, here's my, that represents 2, and it's an open circle because it won't include 2, just 2. All real numbers means everything. Remember, a real number is every single number on a number line. And in this case, it has to be greater than 2, so you're just going to draw it like this, with a line, which means, well, it's supposed to be a line. Anyway, everything to the right of 2, not including 2, is what you're graphing. So that's what you'll be allowed to use. Here's another one. Now this is, we've talked about the trichotomy axiom before. Let's just a little refresher about this. X is not greater than or equal to 3. Well, let's just stop that right there. How do you write x is not greater than or equal to 3? Well, of course, you're going to write x is less than 3, right? Okay. In this one, what numbers are you allowed to use in this problem or experiment or whatever it is? You're allowed to use integers. okay? So again, just draw yourself a nice basic, line here, okay? And again, just start with 3. Don't make a million, just start with 3, okay? So if you start with 3 and you are not allowed to use 3, which means you're not going to be able to use this 3 at all. And the only numbers you're going to be able to use are integers. So that means, remember what an integer is. It's like, 1, 2, 3, 4, 5, 6, 7. It also goes back to 0, and it'd be -1, -2, -3, -4, on to infinity on both sides, okay? So you are allowed to use integers, which means you are not going to be able to use 3. It's got to be less than 3. So what you got here is 2, 1, 0, -1, -2, and so on, okay? Now the weird thing is, this is not going to look like this when you're allowed to use every single real number there is. I mean, here's your 2, right? Here's 3, here's 4. What this graph shows is that every single little infinite variety of a number between 2 and 3, you've got it covered. You're allowed to use all of that. In this one, you're only allowed to use integers. So you're not going to write a line across this and go, oh yeah, I can everything between there. You're only allowed to use 2. You're only allowed to use 1, 0, -1, -2, and so on. That's what you would have to graph. So don't graph anything or cover all the lines in between, because you're only allowed to use the integers. Okay, that's the types you're going to see in this. Okay, here's another one. X is greater than or equal to -1. All right, and let's just draw it here. There's my basic graph, and let's just work on, there's -1. Okay, so greater than or equal to -1. Okay, so we can include -1. And you're allowed to use real numbers. Well, that means everything, every single thing. Between the integers, everywhere in between. It's greater than or equal to -1, so you can go ahead and fill in that one. And then everything to the right, since it's greater than or equal to, boom, there you go. It's every single one of them you can use. Okay? All right, try another one. X is less than -1. X is less than -1, okay? And what are you allowed to use? You are allowed to use all positive integers. All right, so let's draw our graph, or our number line here. X is less than -1. Let's just go -1. So it's going to be everything here. And on this side, we're allowed to use only positive integers. Now an integer, don't forget, is like -3, -2, -1, 0, 1, 2, 3, 4, and then to infinity both ways. Wait a minute. If x is less than -1, we're talking about stuff on this side of the number line, right? But the only numbers we're allowed to use are positive integers, which, let's say this is 0 and this is 1 and so on. Positive integers start with 1. That doesn't match. That doesn't fly. So you can write, in other words, there is no answer to this. There's no positive integer that you can say is less than -1. So remember the 2 ways to write? That isn't even close. That looks like, wait a second. That kind of looks like Lucy from, no, that looks like Snoopy and Lucy. I was trying to draw Peanuts, Snoopy, and Lucy, but forget the whole thing. Anyway, this is the way you write an empty set or a null set. Remember that? Or you can write a 0 with a, I mean, there's no answer to this. There's no way you can list a bunch of positive integers that are also less than -1. Okay, here's our next one. X is greater than or equal to -5. Okay, so let's go like this. Okay, X is greater than or less, greater than or equal to -5. Let's put -5 here. We are only allowed to use positive integers. Okay, well, we can just go from here, -5, -4, -3, -2, -1, 0. Why don't you give that more space line there? 1, 2, 3, and so on. Okay, now remember on the one a couple of pages ago, we did integers. That told us we're not going to use every single number between integers. We're just going to put a little dot on each one. But look at this. There are numbers that are greater or equal to -5 that are not positive integers. In other words, this would be 1, this would be 1, this would be 1, that, we can keep going, okay? But we are only allowed to use this group. So what we're going to do is we're just going to start here. That's a 1, that's a 2, that's a 3, and so on. You don't even have to write this part at all. Oops, I meant just from there to 0. This is how you start the positive integers that are greater than or equal to -5. let's take a look at the second part of what we're doing today, which is called the additive property of inequality. Additive property of equality, we know that, right? In other words, you have a, I don't know, let's say it's a x minus 3 equals 10, right? We know from an equation, we're going to go, oh, if I add 3 to this side, it's an equation, so it means I have to add 3 to this side, right? So we got x on the left side, and then we have on the right side 10 plus 3, and there is our answer right there, x is 13. Because once you do something to one side of an equation, you do the same thing to the other side, okay? If you have an inequality, which is the name of this chapter, not equalities. It's an inequality, which means greater than or less than or greater than equal to or less than or equal to, something like that. You're going to do exactly the same technique. You do the same thing. So go ahead and take a second here and copy that down. This is your inequality, but because it's not equal. There's not an equal sign there. There's a less than. Okay, well, we will treat this exactly like we would just a regular equation with an equal sign. Okay, so what we're going to do is we go, okay, well, I have a minus 2 here and a minus 2 there. And that gives me an x, and that is a less than, and that's a negative 2. So that is our inequality. So in other words, you're going to graph this thing just like a regular one we did just the last couple of pages, right? Okay, but they'll tell you, all you need to do here, well, the only difference is that you're going to set this up to where x is by itself on the left side and everything else is to the right side. So your domain, in other words, what am I allowed to use? You are allowed to use real numbers, which means all of them, okay? So here's your basic graph. This is a real simple one, and again, make this real easy on yourself. Don't try to draw all these little numbers, just do it as fast as you can. I hope this can be one of those problems and Saxon can zing right through, take 30 seconds to do. Okay, less than negative 2, you're allowed to use all the numbers on that number line. We'll put an open circle there to show that we're not going to use negative 2 itself, but everything else goes to the left. Boom, like that. And a nice even line. Ugh. Anyway, okay. All right, here's another one. Take a second and pause it if you want to. Copy this one down. Okay, well, this looks, just another inequality. And what are we going to do to take care of that negative 3? We're going to add 3. Plus 3 here and plus 3 there. And then down, and then greater than or equal to, and then negative 5 plus 3 is negative 2. Okay, so this is our inequality. What am I allowed to use? I'm allowed to use integers. Okay, so we draw a nice simple, here. And since it is greater than and equal to negative 2, that means it will include negative 2. So you'll write something like this. There's my negative 2, and I'll fill it in, boom, like that. It's going to be greater than or equal to, so my next integer is negative 1, and then 0, and then 1, and that's enough. We know what the deal is. Don't spend a ton of time writing 15, numbers across the thing. Just, And by the way, the answers in the back of the book on these, they might have more examples. They might go to 2 and 3 and 4 on theirs. You know what the deal is. You know what you're trying to get at with your drawing if it doesn't have as many, so good enough. Okay, that's your answer. And the reason there are dots on those is because we're choosing integers only. We're not doing the numbers between those. Okay, that is it for the lesson. Try the practice set, and you can just try A first, and pause it and then try A. Okay, well, if x is not less than or equal to, that means it is greater than negative 2. What are we allowed to use? We're allowed to use positive integers. So, there's your basic line. You don't have to draw negative 2. Well, here, a question for you. Okay, it has to be greater than negative 2, and we're going to put positive integers. Well, what's the first positive integer, which is also greater than negative 2? What's the first positive integer? 1, right? Okay. If you wanted to, you could write the negative 2 over here and, whatever. But you could just also, if you wanted to, just write, 1, 2, 3, that kind of thing. And then just, put little dots there. And again, the reason you're doing that is because we are only allowed to use integers. That's called the domain. Okay, pause, try B. Okay, if B is not less than or equal to, let me make doubly sure here. I might have that. Okay, yeah, that's right. Okay, if x is not less than or equal to 4, that means x is greater than 4. And it's x is greater than 4, what are we allowed to use? We're allowed to use all real numbers. So real simple number line, there's our 4. It does not include 4, it's only greater than 4. So open line and then, or open circle there, and then everything to the right of that of 4. Okay, pause it and try C. Okay, well, let's rewrite this. First off, let's go ahead and go with, it's just going to be x minus 5. If it's not less than, that means it's greater than or equal to. So that's in blue, that's what we're looking at messing with now. So we know we're just going to add 5 here, and we're going to add 5 here. So our new inequality turns into x is greater than or equal to 5. Okay, that's what we're piddling with. What are we allowed to use? We're allowed to use only integers. Okay, so here's our number line, real simple. If it's greater than or equal to 5, that means, if it's equal to 5, that means we can include 5, right? So this is 5, and our next integer is 6, and then 7, and that's probably good enough. Okay, which means we're going to fill in this here, fill in that there, fill in that there, and so on. Okay. All right, last one, pause it and try D. Okay, well, let's look at our inequality. We're going to take away 2 from both sides to make it work. And now we have x is less than 3. All right. What are we allowed to use? We are allowed to use integers. That's the domain. Okay, so real simple number line, less than 3, integers. Okay, and again, you don't have to write the number 3 on here because you know you're only going to be allowed to use numbers that are less than 3. So if you want to, you know, what's the first number less than 3 that's an integer? 2, right? Okay, so you can start with 2 if you want. There's a 2, there's a 1, there's a 0, there's a -1, there's a -2, and so on. Okay, you don't have to write that many, but if you want to, it's fine. Okay, so we're gonna put little, you know, we're gonna fill this in, fill that in, fill that in, fill that in, fill that in, and so on. Okay, and again, the reason we're not using all of it like this is because they tell us we are only allowed to use integers on that one. So that's what it's going to look like. So, okay, see you guys. Have a good day, and we'll see you next time.